Okay, so if you're trying to do elimination, you are taking a problem that's got x's and y's and eliminating them. So you either add or subtract the equations. False. Already, I don't agree, because I think you should always add straight down. Your life is simpler. Just always add. Always add. I'll show you. You add straight down. So watch me add these straight down. What does 4x and negative 4x add up to? 0. They're gone. Yay. See how they eliminated? And if I add the 8 and the 2y, that makes what? 10y. And if I add these two, I know there's a minus there, but you still should think of it as adding. What does 10 and negative 30 make? Negative 10. And then the answer is y equals negative 1. Can I stop? No, because your answers are always x comma y. And y is negative 1, so what's x? Everybody, plug negative 1 into either equation. I don't care which one. Whichever equation you want, but stick in y equals negative 1. Corey, you using the red one or the green one? You get to pick. Don't work too hard here. Okay, and we're going to put in negative 1 where?
For y.
Yep. So here's the negative 1 going into the red equation right there. Would you reread me the red equation now? 4x, keep going.
Plus negative 8.
So I'm just going to say minus 8. It's the same thing. Equals 20. And then can you solve that?
Plus 8.
Good. Then what?
And then
28 divided by 4. He's right. What's the final answer, everybody? 7. So it was 7 comma negative 1. You get when you get your two answers, you have an x, you have a y. Just put them in a little point. And that's what you would have gotten if you would have graphed them. But believe me, you wouldn't have wanted to graph these. Can you tell me why this would be so hard to graph? Because they're not what? Why are these tough to graph? How about this? Let me show you ones that wouldn't have been tough to graph. What if it had been like this? Y equals 6x minus 4 and y equals 10x minus 2. Those would not have been hard to graph. Yes?
They're not linear.
Okay. They are still linear. These are lines, but so are these. These are lines. But what makes this easy to graph and the other one's hard? Yes?
It's already in the y.
Yes. If you have y equals, those are easy to graph. If they're not set to y equals, if they're not solved for y, then it's not going to be easy to graph. So then this elimination thing is pretty cool. What we just did there was called elimination. Let's do it again. If I go to this slide, draw a line across. You're always going to draw a line across like that. Next, got to ask yourself, if I add straight down, is something going to eliminate? Yeah, something will. What eliminates?
9.
The 9. So these are gone. And I know some of you are bothered by the whole like add, subtract. Am I subtracting or am I adding? You're adding. But you happen to be adding a negative. And so what do you get? 2x equals, what do these add up to? It just happens to be negative one of those two. Negative 2. So then, next step, divide by 2, negative 1. Raise your hand if you had negative 1. Awesome. Get what happened there? Now, how do you finish it? Corey, I got negative 1, but I'm not done. Do you know what to do?
Plug the negative 1 into the x.
Excellent. Do you want to use the red one or the green one?
We're going to do the green one.
Okay. In the green one, I'm putting x as negative 1, which is right there. And then I get negative 4. Do I have to actually rewrite this whole thing? Nope. I'm lazy like you. Like everybody. Yay, now it's negative 4. Now what's the next step, Tuck? Solving the green one.
You add 4 to both sides.
I agree. Plus 4 plus 4. and 9y equals 27. Then I'm pretty much done. What's y equal to? 3. I got an x, I got a y. 1, 3. There we go. I put it in a point form. Now I noticed on Schoology, sometimes they didn't want it in a point form. Oh, it's kind of annoying. It's because I never know whether they're going to want it in a point form or not. But they'll tell you in the Schoology quiz whether to put it in a point form or not. Okay. So, do you get that after we have done elimination on these two, the easy part is, oh, I know one of the numbers, I stick it in the equation. Do you know when you were in algebra, that was the whole job? Was they'd say, in this equation, put in y equals -1. That was the whole job. Now, it's just the end of the job. You know what I mean? It's like you do a bunch of work, and then you start one of the problems that you would have had in algebra. That's why higher algebra is harder, because you got to do a bunch of work to get an answer, and then you take that and you go do what would have been the whole question in regular algebra. So this really depends a lot on stuff you used to know. Maybe you've forgotten. All right, trick question here. Seems like those 6x's would disappear. They aren't. So what the heck do you do? Let me give you a hint. If you wanted to, you could go through and multiply all of the ones that are green ones by something. What could you multiply them by so that this would actually work out pretty good? Yes?
3.
3 would work, but there's something simpler. I can multiply everything by -1, yes. Now, think about y, because when you multiply a -1, it's opposite day. It just changes everything's sign. Do you get if I multiply by -1, it changes negatives to positives, and it changes positives to negatives? It's like opposite day. All right. So then, this is positive 6x, which will cancel negative 6x, and then I get elimination, which is what I wanted. This is gone. It's out of my life, just like I said. I wanted to get Diet Dew out of my life. Very addictive, though. All right, so anyway, 6y minus 3y is 3y. And I'm hoping you know that that's positive 12, because there was 2 negatives. And the 6 makes 18. Y equals 6. Who had 6 before I even said it? Nice. Any questions? Yes?
I don't really understand any of this.
Okay. Good. I'm glad you're asking. So, what I did to be able to start this problem is I looked at the problem and I said, if I just add them straight down, nothing will disappear. Do you get, if I just add them straight down, that and that don't cancel, you know, because they're both negatives, both negative 6x. So I got to think to myself, what can I do? I can multiply by -1, and that'll make this positive 6. And I multiply by this by -1, and it'll make it -3. And I multiply this by -1, and it makes it positive 12. And why is that better? Because then they will cancel. Does that make sense to you? That's why I wanted to do that. I multiplied the whole bottom row by -1.
Yeah, kind of.
Okay. There's another way you could have done it. How about we just move on to a different problem and see if it starts to, like, click for you on the next one. Yes?
If you go to find out what x is, with that, do you keep it changed?
Oh, good question. You can either use the original green equation or the changed green equation. It doesn't matter. In fact, the easiest thing is just use the red equation because you never messed with it.
You can use either?
You can use either, yes. And that's a good point, because sometimes when you're doing substitution, you can't like solve something in the first equation and then put it in the first equation. You always have to like move equations. You get to put it in either equation you want. All right, the next question. Everybody look at this one. And this time, if I add them straight down, it doesn't work at all. It's not even like just opposites. I don't have to like just change the bottom row to be the opposite of itself. It just isn't working at all. Who knows what to multiply the green one by? Raise your hand high. I see one person so far. All right, give it a little more time. I think more people are going to see it. This is what's called wait time. Now I'm up to 5 people. All right, what do you think, Luke?
3.
All right, tell me why. Is it because of this first one? Is it because of the second one? Or is it because of the third one?
It's because of the second one.
Yeah. What happens here now?
Well, the 5 times 3 will become 15y, and then those two will cancel.
Yeah, because you got a negative 15 and a positive 15. Nice. Do you get that's the whole point, is to try to get these to cancel each other? And they do, if you choose the right thing to multiply by. Mariam, could you finish this one? I got negative 4x and I got negative 3x. What do these guys make? Yes, you are correct. And then I'm going to help with this one because it's kind of gross. 3 times 13 is 39. Negative 39. Now I got to put it together with that negative 17 and make negative, who can do it? 56. Yes. And then you instantly, at least I do, I instantly look at this and go, oh, it works. 7 times what makes 56? 8. X equals 8. Corey, why can't I just stop? X equals 8, I'm done.
You gotta put
Yep. And we had a question earlier. Can you put it in either one? Yup. You can put it in the original green one. You could put it in the green one after we multiplied it all by 3. Or you could put it in the red one. It doesn't matter. I'm picking the red one. I'm feeling red. So there, my 8 goes in there. And I got, I'm going to write it over here, negative 32 minus 15y equals negative 17. And now look, we're halfway through the problem and it turned into algebra. Do you get if a kid right here didn't know how to solve this? They're toast. It's halfway through, but they'd be stuck and they'd be done. That's why we worked on all those basic 20s to try to make sure you didn't get stuck right here. But if you knew your basics, you knew that we added 32 to both sides. And then it's negative 15y equals, that's not fun. Somebody save me some time. What is that? 15. I'm going to double check by adding these two. Did you guys know that worked? Yeah, that adds up to 32. So yay, that's right. And it makes sense. 15y equals 15. So Tuck, final step.
Drop at negative 15.
Final answer.
Negative 1.
Y equals negative 1. Holy cow. So after getting x equals 8, it was like 10 minutes later I finally finished this stupid problem. 8 comma negative 1. There we go. You're in higher algebra. Lots of algebra. So yesterday, side note, I taught you about the quadratic formula. And don't go look it up. But it was that big, long, 16-part formula. Now, some people say kids nowadays have weaker memories than kids when I was your age. Now, I'm not sure I believe that, but here's the argument. Memory is a muscle. So if you don't use your memory, because why? Why would you guys use your memory less than me? You guys have a phone. Do you get that almost anything you would need is in your phone? Like the directions to your house. I bet a lot of you that live far away from here, if you had to actually walk home from here, it'd be a little intimidating. Like, I'm not sure exactly where to go because the phone has always told you. And if your phone died or wouldn't work, you'd be like, dang, I got to walk there myself. I don't know how to do it. So if your phone is keeping track of everything and you have anything important and you're like, oh, I'll just type it in my phone. I know it's true for me. If I have anything important, I just put it in my phone, and then I don't have to worry about remembering it. But memory is a muscle, and your memory might be getting weaker because you aren't using it. Anybody ever had a cast on their arm or their leg? Ooh, a lot of you. Okay. Did you ever have a situation where you took the cast off and then you try to use the muscle? Do you remember what I'm talking about? So you still remember it because the muscle gets so weak in there. In my case, I broke an arm. It was my left arm. And I remember I could barely move my wrist, just like an inch. And I couldn't even move it anymore because the muscles had basically gotten all screwed up from atrophy. So all I'm trying to say, your memory is like a muscle. And if you haven't been using it, it's probably weak. Just like the muscle on my wrist was really weak when I took off the cast. So my point, if you ever need a really strong memory, if your memory is a big deal, do you get it as a big deal for doctors? When they take their medical exams, do you think they can use the internet? No, you can't just Google your answers. You know what I mean? When they have to look up the name of the 205th bone in the human body, they're going to have to know that one by memory. So they need to have really strong memories. The memory champions use their memories a lot, and then they get to be memory champions. You, if you decided to, could be a memory champion by 2 years from now. You could be able, if you wanted to walk into a room and just be introduced to each person, all 30 kids, then go into another room, another 30 kids, and then go in another room, another 30 kids, and go into 10 rooms like that. And then have a random kid chosen to walk up to you, and you could know their name. If you just work at your memory, you can get a memory that strong, okay? So anyway, I'm just doing a little interesting thought experiment. Are you getting a weaker memory because you have a phone? I don't know what the answer to that is. I think it's actually yes. But I think if you worked at it, it wouldn't take long to make your memory just as good as anybody's ever was. All right, so on that note, you've had plenty of time. Who knew it was x equals negative b plus or minus the square root of b squared minus 4ac. All right, and if you use a song like I heard some people singing, like I taught it with that song yesterday, it helps you remember it. And so I encourage you, whenever you can, set something to music's a great way to do it. Another way to do it is to tell a story. Did I ever tell you the story of the Fight Club yet? All right, I'm going to tell you a story, and then that'll help you memorize another big formula that you're supposed to know. And this is the second biggest formula. That was the first biggest. That's the biggest formula you have to know. This is for solving quadratics. And by the way, just a side note, if you had this x squared plus 6x minus 7, then a, well, there is no a. No, there's something there. What's there? 1. B is 6. C is negative 7. And then you just stick them into a, b, and c. And you end up with a weird answer like 1 plus or minus the square root of 6 all over 5 or whatever. Okay, here's the second biggest formula, and I'm going to tell you this story just because I eventually have to tell you the distance formula. You and a friend on Saturday night decide to go to a fight club. Imagine here in your hometown, there's a fight club, and it happens on Saturday nights. And you don't have to fight, but you can just watch the fights if you want to. And the fight is happening when you walk in that big, long warehouse. It's like somebody's garage in their backyard. And the fight is between two guys. And they're squared up against each other. See what I did there with the squared? Yeah, see what I mean? Because squared up also could mean in a fight, like having your shoulders squared with the other person. All right, so they're squared up against each other. And then you walk from the one fight to the back of the warehouse, and what do you think is going to be happening back there? another fight. And it's not two guys. In this case, it's two girls are fighting. And then on the way to that fight, this is so important because it's you can try to remember which would trip you more, a minus sign or a plus sign. Which would be more trippy? Plus. And that's what you trip over on the way from the one fight to the other. And you're like, who puts a plus sign in the middle of a big garage? This doesn't make sense. Oh, it must be a math teacher. Anyway, that is the distance formula. Fighting is a negative thing, right? And don't forget you tripped over a plus sign. And then that's it. And now that has a lot of characters, but yet by me just telling you a story, it's much easier to remember. What's the first thing? What do you walk into? Square root. What do you see in the first parentheses? But it doesn't matter if it's x's or y's. It doesn't matter. As long as you get it wouldn't be an x and a y. Okay, they've got to be the same. All right. And then squared. Very good. And then on the way to the other fight, what happens when the way to the other fight? Tripped over the plus sign. And then there's a y minus y here. And then there's one little thing missing. Squared. And look at that. Let me show you how many pieces there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Interesting. It's the same number as the quadratic formula. But people consider the quadratic formula harder. Probably because it's got a plus minus sign in it. All right. So, moral of the story. That's what you'd use if you had 2 points and you needed to know how far is 2, 5 away from 3, 9. You'd stick the x's in here. And by the way, it doesn't matter if it's 2 minus 3 or 3 minus 2. You don't care because you're squaring it. And then you put the y's here. And you don't care if it's 9 minus 5 or 5 minus 9. So I'd use 9 minus 5 because it's easier. 9 minus 5 is 4. And then you square it. And then you got 16. And the other one? The other one was 2 minus 3 or 3 minus 2. I choose 3 minus 2. And it's 1. And then it's 1 squared, which is 1. Final answer, square root of 17. Do you get how that story might help you remember that one? So we've got a song for the one and a story for the other. It'll really help you to do it one last time. Everybody go to a blank spot on your page and write the distance formula yourself, because it'll stick way better. What is the distance formula? If I just asked you to memorize 16 random things in a row, you'd probably mess up the pluses and the minuses and the stuff. In a moment, I'll have you compare with the kid sitting next to you and see if you've actually got it. So today's lesson is really about elimination, but at some point yesterday, a lot of you guys didn't do so hot on that 5-question deal, and I'm going to recommend that you maybe go back and do it again because you get unlimited retakes on that quiz, and you get the highest score. You don't get an average. You just get the higher one. So if you want to practice that one again, you could. But let's get to this one. Now, as you can imagine, as we're moving on, the problems are getting harder. This time, if I just add straight down, nothing happens. Nothing eliminates. Doesn't work. And if you times by just one thing, there's nothing you can times by that's nice that makes everything go away. Now, you could multiply by a fraction, but that'd be nasty. So let's not even think about that. But do you get that if I times this one by 5 and I times this one by 2, do you get then they will both make 10? So that's what you do. The whole bottom one by 5 and the whole top one by 2. Do you think I just randomly guessed? No. I looked at these two numbers here, and I said to myself, I can take any of these combos and multiply by the other number. 5 and 2, they're just reversed. So what could I have actually used here with the 4 and the 3? I could have multiplied the bottom one by 4 and the top one by 3. That would have worked. Either way would have worked. There's more than one way to do this. Pausing for a second. So I'm going to continue from here, and these two will cancel. I don't need to multiply them all the way out. I know that's going to be a 10. I know that's going to be a negative 10, and I know that means they cancel. Poof, they're gone. And this is an 8, and this is a negative 15. Now, you might not be as good at math as I am, just because I'm a math teacher, but I'm pretty sure that that's negative 7y. Did anybody get the same thing as I did? Okay, good. And then this last one is 12 and negative 5. What is 12 combined with negative 5? 7. So y must equal negative 1. And I'm not going to even finish it, but I think you would know that the negative 1 gets to go back in to one of the equations, don't care which one, and you'd be able to solve for x. It's called back solving. Okay? Ellie.
Can you times it by 4 and 3?
Yes.
Okay.
Let me show you. I'll just do it super quick. That would have worked fine too. I could get the y's to eliminate by choosing to multiply the top one. And it's not like I'm like a super genius. I just look at the two numbers and I go, well, it's a 4 and a 3. So take the 4 and times it by the 3 and take the 3 and times it by the 4. You know what I mean? And then I'm going to go do 3's everywhere because that's the rule. If you do it to one part of the equation, you got to do it to all the parts. There, now the whole top was times by 3, whole bottom was times by 4, and these two cancel out. That makes 15, and negative 8x makes positive 7x equals 18, and negative 4, 14. X equals 2. Cool. All right, so that's it. You've made it. Your assignment is a Schoology quiz on this. There's not that many problems on it. Several kids finished during class hour, which means they walk out of here with no homework. So I'm going to encourage you to try for that. At a minimum, everybody get it open so I can see you are still awake and trying. And that's all I got for you for today.